Hey guys, welcome to Kubernetes Community Day Sri Lanka 2022. Hope you guys are doing well and enjoying a lot of talks today. In this session, I will discuss about Web3 and Kubernetes. So let me introduce myself first. So my name is Arpan Adhikari. Thanks for having me today, and I'm a software developer at CodeClouds. You can contact me via Twitter, LinkedIn, or Discord. So without wasting time, let's just jump in. So we will talk about Web3 and Kubernetes. So we all are aware about the both the technologies, right? So Web3 is the decentralized network, and Kubernetes is used for orchestrating the cloud or orchestrating the containers, to be specific. So how we can combine those? So how we can orchestrate Web3 with Kubernetes? So where we can put Kubernetes and the Web3 architecture. So let me go to the index page, and we will start with briefing about Web3. Then we will discuss about blockchain. Then we will discuss about Ethereum and Geth. So Geth is a package of Ethereum written in Golang. So we will discuss about that. Then we will share details about, just a recap about containers and Kubernetes. Then we will do a elaborative discussion on how we can integrate Web3 and Kubernetes together. Then we will do some hands-on on creating some Ethereum nodes on the Kubernetes cluster using Helm. And at last, we will test that using JSON RPC. So let's start with the first slide. So what is Web3? We all heard about the term Web3. So we are using Web 2, right? So what was Web 2? So Web 2 was centralized, that helped us or billions of people to come online, and in this process, the whole power of this web gone to the hands of these large tech companies, so they can control the web today. So to just answer to this dilemma, we introduced the Web3. So Web3 is built by the people like us. So it is totally decentralized, and this web monopoly created by these tech giants are removed by introducing Web3. So we can integrate Web3 using the blockchains. It is made possible with the help of blockchain and decentralized networks and those things. So what is blockchain? So what is blockchain? Blockchain is a data structure which is a growing list of blocks. So blocks are linked together with hashes. So if you tamper data, the hash will change, and you can't validate that blockchain. So in this way, the blockchains are very secure, and these blocks cannot be removed. So if you remove or tamper the data or alter the block, then the data will be changed, and with that data also the hash will change. So when the hash changes, you can't validate it. So in this way, a blockchain is totally secure. And then we have a question in mind, right? So we are familiar with Bitcoins. So is Bitcoin a blockchain? No, Bitcoin is not exactly a blockchain, but the underlying architecture of Bitcoin is blockchain. So Bitcoin is a currency that uses blockchain as its underlying architecture. That's it. And we can see this is a blockchain diagram. So you can see block 1, block 2, and block 3. All the block contains a hash unique to each of the blocks, and also they contain a previous hash. So each block has the hash of the previous block. So if you tamper data, then the hash will change, and then the block cannot be verified. So it is unauthorized to change the block. So you can't change a block in a blockchain. So once it's written the block, it is secured and cannot be tampered. So how the next point is how the industries are getting benefits from blockchain. So I have just pointed out some of the major benefits from the blockchain technology. So banking is the one of the best application of blockchain. So we are seeing the many of the industries are accepting blockchains. I mean cryptos. So they are implementing the blockchains for trade finance, so for clearing the settlements, consumer banking, lending, and all of this. So these are the applications on the banking and financial industry. And then for the healthcare, we the help of blockchain, the data on the healthcare sector can be more secured and can be shared with the providers, payers, and researchers more securely. And for the insurance sector, most of the things are done by written or via today they are moving to the cloud. But with the help of blockchain, the claim settlements and the process of insurance and other documenting stuffs will get much easier, much efficient, and it will also reduce the cost if we integrate blockchain with the insurance industry. So let's talk about Ethereum. So what is Ethereum? So Ethereum is also a blockchain protocol, and it uses Ether like Bitcoin. It is BTC. For Ethereum, it's Ether. So with Ether, we pay the transaction fees and all. So the transaction get written into the Ethereum blockchain. And we know that Ether is the second largest cryptocurrency, and it represents approximately 20% of the cryptocurrency market capitalization. And why Ethereum is so much popular, because currently we develop dApps, and those dApps are mostly based on smart contracts. Those smart contracts are written in Solidity. So Solidity is a language for Ethereum. So we can write smart contracts for Ethereum, and with those smart contracts, we can define NFTs, we can define multiple tokens, whether they are fungible, non-fungible tokens. So those are the separate discussions. So we won't get deep into those, but just an overview of that. So most widely, Ethereum is used for the DeFi application. So DeFi is for decentralized financial applications, and the NFTs. We are all aware about the NFTs, that those are non-fungible tokens. So most of the artworks and those like are the NFTs we can trade. Also, there are lots of application of NFTs, like for we can use NFTs to get entry to some events, so and so on. So we will use an Ethereum node. So what is an Ethereum node? So we need Ethereum node to validate all the transactions and the new blocks of the Ethereum chain. They operate in a point-to-point fashion. Each of the Ethereum node contains the copy of the entire blockchain. Ethereum also has some light nodes. Those contains only the block headers. So they provide easy verification of the tree data structure, and they do not execute transactions. So used for primarily for balance validations. And they are implemented with a lot of language like Go, Rust, etc. Now, why we need to create our own node? So we already have some options like Alchemy, Infura, Tatum, etc. So why we need to create our own node? Because these platforms has some limitations. So let's say they are limited to some API calls. So if you reach that limit once, so you have to pay for a much higher plan, or even your infrastructure is down, your whole decentralized application will get affected. So to control over that data, you have to create your own node. So in this session, we will create our own node and talk to the Ethereum chain. So we will say later that. And so what is Geth? So Geth is a Ethereum package of Go implementation, and we will use that to deploy Ethereum node. And with that node, we will talk to the Ethereum chain. You can find more about Geth, and depending on your system, you can install Geth. You can visit the geth.ethereum.org and you can download Geth and run your own node. So let's do a quick recap on containers. So what is container? So container is a standard unit of software that packages your whole code with their dependencies. So it solves the problem of it works on my machine, right? So if you move that container to any of the environment, to my machine, to your machine, to another machine, it will work. So that is a container. And the Docker container image is a lightweight, standalone executable package of software that includes everything to run the application. So it has the code, it has the runtime, the system tools, and system library settings, everything. So container images are used to create the containers. So container images become the containers in the runtime. So again, just a quick recap on Kubernetes. So Kubernetes is an open source container orchestration engine. So we can control over the containers and the pods. So how they can be controlled, how they can be initiated and all. So Kubernetes is highly extensible and portable, and it is an open source project by Google, now a part of the Cloud Native Computing Foundation. And developers and administrators use it to describe how they want the system to behave. So they have control to the whole architecture. And Kubernetes executes the desired state in a dynamic fashion. So if you want to have like 3 nodes, and if one node get down, then already Kubernetes do make another node, so you already maintain the 3 nodes up architecture. So why we deploy the Ethereum node on Kubernetes? So first thing is the scalability. So if our node get too much traffic, we can scale it with the help of Kubernetes. And next point is the painless upgrades. That means Ethereum, actually Go Ethereum packages is released in very few gaps, so very few time gaps. So you need to upgrade your Geth package for security issues and all. So to get those upgrades and deploy it, it is very easy with Kubernetes to upgrade your Geth node. And also the availability. So if you do deploy in the nodes in the Kubernetes, so availability is not just a concern. And what we will be doing in this demo, so we'll create a Kubernetes cluster, then we will use the DigitalOcean cloud, and we will create a Kubernetes cluster. Then we will deploy the Geth using Helm, and we will add the load balancer to it so we can access it over the internet. And then we will test the JSON RPC response from that node. So let's do some hands-on. Let me share my Safari screen. I think it is visible now. I am on the DigitalOcean page. Now let me head over to the Kubernetes section. First, I have to create a cluster to deploy our nodes. So I will choose the Bangalore, and I will left the VPC network as default. I will select the latest version. Then I will choose the basic nodes, and it will be $12 per month. That is the cheapest one. And then I will reduce the node counts to 1. Since this is just for test, so you can do it as per your requirement. Let me choose the project. Now let me add a get cube. So I will add a tag to it, and let me just click on the create cluster button. So this will create a Kubernetes cluster on this DigitalOcean cloud. So this is really easy to just launch your Kubernetes cluster. So we have to wait for it. It will take some time to launch the Kubernetes cluster. We have to wait for it. We can see the progress here. It will take around 4 to 5 minutes to create the Kubernetes cluster. Once it's created, we will check the connection from the terminal. I will refresh the page. Since this is from the back end, it won't hamper their progress. So temporarily we can see that there is no progress, but after some time it will be, yeah, you can see the progress is the same. So it will take some time, so we can just see the cluster info here. We added this tag. These tags are automatically added by DigitalOcean. So let's try the cluster here. We do not need to go to the marketplace. Inside resources, so we can see the node pool is getting created. So from that pool it will create a node, and it will deploy the cluster. So let's just wait for a few minutes more. Then we will just head over to this page. So if you do not have already doctail command installed, you can install from the official documentation. I have already installed into my system, so I can just copy it. Let me open the VS Code. I think it is visible now. And let me just paste the command we just got from DigitalOcean. So I just hit enter. We got 2 notices. So let me head over to the Kubernetes section again. So here's the Safari. Turn off the VS Code for now. So I think it is visible now. Okay, so you can see the progress, and you can see the notices. We saw these notices already, so we are good to go, but our cluster is not ready yet. So once it is ready, we will get the node message as ready. So let me share the VS Code again and hide the Safari. we'll hit kubectl get nodes. If we get the nodes are ready, so we can deploy the get back. So you can see the status is not ready. So our node is on the Kubernetes cluster is not ready yet. Again, it's still getting created, so it takes some time. Yeah, we can see it is ready now, and we will start deploying it. So let me just copy the command for Helm. Okay, so if you want to deploy, I will share the code in the references section. Also, in this values.yml, you have to change this address, private key, and secret with your own wallet address and private key. So you can create your own wallet using any of the providers. So there are no foundations. You have to put that in this file and you can run this command. So helm install, then we have to mention the package name. So let me use getcube. Then we will just hit deploy. So okay, so there is a directory issue, so let me just remove that values.yml and place the correct path. So it will be stable, then Ethereum, then values.yml. You can see we got a message, so it will be deployed. It will take some time to deploy the package, so we can write like kubectl get all, so you can see the processes of the pods are getting created. You can see, so one pod is ready, so second is 0 out of 1 is ready. So if we refresh this after some time, we can see all of the pods are ready. Okay, so all of the pods are ready, but you can see the load balancer is still pending because it is assigning the IPs from the public IP pool. So it will take some time to assign out IP to load balancer. Once the load balancer's IPs are ready, we can use it. So let's just wait for it. So once we get those IPs, we can run the getcube itstat service, so we can see the Ethereum status of our node on our dashboard, and on the other place we will use and hit the 8545 port and get the JSON RPC response. So let's just wait for it. It will take some time, so let me run kubectl get all again. So we have to wait for it, I think. You can see it still, it is pending. We have to wait for 3 moments more. I know this is annoying, but we have to wait for it because it takes some time to assign the IPs. So let's just wait for a few minutes more. Normally it takes 5 to 6 minutes, so depending on some circumstances it can vary. So depending on the time you're deploying your cluster, it will vary. So kubectl get all, let me run it again. you can see we got our IPs. So let me hit the Safari with this IP first. So let me open a Safari. So here it is. So let me open a new tab and paste that IP. So you can see the Ethereum status. So yeah, it is up and running. So you can see the node is up and running, and you can see the status. So if you do something on this node or contact the Ethereum chain with this node, you can get the logs and everything on from this dashboard. So it is ready. Now we will hit that another load balancers IP to get our JSON RPC response. So I will open Postman first, and I will open the VS Code first. So let me hide the Safari, and I will copy the another IP. So it will be like this one. Let me, and you can see the port here is 8545. So I also have copied, I remember the port number, and now I will open up the Postman. So let me open Postman. I hope you can see the Postman. So I will hit the Postman with a sample JSON RPC request. So let me replace the IP. So I was testing with this IP. So let me just replace with the current IP. So I already replaced. So I missed the semicolon. Okay. So you can see we got a 200 response, and our JSON RPC is working perfectly. So we have successfully deployed a Web3, that is Ethereum node, on the Kubernetes cluster successfully. So let me get back to the slides again. Okay. Okay. So let me slides. Okay. So if you have any questions about this session, you can contact me on Twitter or LinkedIn. I have shared my profile links, so you can contact me via Twitter or LinkedIn. I'm available, and I will get back to you as soon as possible. So these are the references, and you can get all the codes from this link and other topics and more details. For the more details, you can visit these links. So thank you for having me. Thank you for thank you to the organizers for organizing such a great conference, and first time for Sri Lanka that they organized the Kubernetes Community Days. Thank you, everyone.